My name is Thomas, and today I'm going to give you a quick demonstration of the RepMine system. Here is the front page of the system, and it's what we call the pattern or query graph repository. As you can see, we have two query graphs in here. Both have been modeled on the Xeon ontologies, which is a family of ontologies describing software evolution, which was created by the University of Zurich. Let's have a look at one of those graphs here, commenting on an issue. For this demos, it's pretty straightforward. We have issues have comments, and comments have been created by stakeholders. If we look at the second pattern, it's even simpler. Basically, what we describe is that somebody performed a commit to the source code repository. We can have a look at the resulting Sparkle queries and also run it on some sample data that we have present in our repository. So if we look at the results, we see each commit happening along with its author. So these queries alone are not very spectacular, and so let's do some calculations with them. For that, we create a metric, and for the sake of demonstration, let's check on the contribution of each individual person here. And what we have to do for that is basically group by stakeholder as user, and then simply count the commits as commit count. Okay, so now we can save this metric and now monitor it on our dataset again, and we have no results present yet, but we can just run the refresh, go into the web view, and then we see for each user how many commits they contributed. So far, we only looked at a single data source, which is not very much the use case for RepMine, so let's add a second one. In this case, we have this data set here. This stems from a Neo4j graph, which basically was built upon parsing the GitHub API. Of course, such a Neo4j graph does come with some nodes, and those nodes have labels, but it doesn't have a schema or even an ontology describing it. So what we first have to do is extract that. Now, a custom implementation in the background kind of parses this Neo4j graph, extracts on node their labels, the relationships between the nodes, and of course the attributes that each node has. And once this is done, we have an ontology that we can use kind of to proceed further. Because what we want to do now is basically monitor this contribution metric also on our new repository. Now we do that, and what happens now in the background is the system determines that these two ontologies have not been matched yet, so it performs an automatic check in the background and determines whether or not there are similar classes that can be found, and we're automatically redirected to translating this query, that is the foundation of our metric, to terminology describing the new repository. As we can see, there's already a node, GitHub commit, and if we look at the correspondences, we see that this SW2 GitHub commit refers to the Xeon commit. We can also highlight that. Okay, so what we now have to do is provide equivalent elements for the remainder of this pattern here on the left. So let's create a node, and well, the equivalent for a stakeholder is basically our GitHub user, and kind of what this relationship here is in our terminology that somebody is the committer of a commit. Okay, so now we save the pattern, and the system now asks us kind of to externalize our internal thought process. So we just have to say, okay, this GitHub user here is the same as this GitHub stakeholder. Let's save this mapping, and this is the same as that. And so everything is matched. So now we can go back to the monitoring. We see, okay, contribution can now be calculated. the system is now creating a Neo4j query in the background and querying the interface. And as you can see, we also get the commit count for well, the same elements on a different repository modeled on a different ontology. Now let's go back to this commenting on an issue pattern, and now we also want to translate that to the SWT GitHub repository. As you've seen, we've already translated at least the stakeholder, which was also part of this one here. So this should be already set. Yeah, and we see that, okay, we have a GitHub user, we have a GitHub issue. So what all that needs to be done now is create equivalents for the comment. Let's do a quick search, and we see, we have a GitHub issue comment, which is basically the same. Let's check if there is a relation. No, there's not a relation. That's because there's no explicit relation here in the Neo4j data, but this is more or less indirect. So we have a GitHub issue. This issue has an URL. We store this URL in a variable called issue URL. And now what we can do here with the issue is simply refer to that variable, and here is stored in the issue URL field, and if that equals the issue URL, so this one here, then those two are equivalent, and the GitHub user, let's see if there's at least a connection, not this way around, this way around. Okay, and so then we're basically good to go. So comment is fairly straightforward. Those are equivalent. This has offer is this one here. And is comment off is basically expressed by those two attributes. And now we're good to go and can kind of use this query also on both repositories. So as you can see, basically what we do here is model query graphs in the system. In the background, there are automatic matching tools running, figuring out kind of the tedious work, figuring out there are two issue classes. And so we only have to take care about the peculiarities in the mappings and not the petty stuff. So thank you very much for watching, and please give us an email if you're interested in using our system. Thank you very much.